everyone. Thank you for attending a day which I won't say is like the Arctic, but I'm from LA, so far as I can say it is. But my name is Victoria Sampson with the Secure World Foundation, and we're very excited about this panel of experts and this topic that's developed to be a new issue area for us. So I'm looking forward to learning a lot from experts in this panel. I think I know most of you, but for those who are new to our organization, the Secure World Foundation is a private operating foundation that works to promote the long-term sustainable use of space, largely because it is intensely tied to our daily lives, our economic activities, and national security. Our interest in space is not just for its own sake, but for what it can bring to socioeconomic benefits on Earth. As such, we also look at how space can be used to enhance human and environmental security, which is where our interest in the Arctic comes in. The Arctic region is changing rapidly, allowing for new opportunities to learn more about this remote area, used to expand economic development, and build off it for national security and political benefits. However, there are challenges involved in ensuring that there is assured access to the Arctic, monitoring physical changes it is undergoing, using the Arctic in a sustainable manner, and creating a stable environment for a region that can set off geopolitical tensions. These challenges have created the need for scientific and technological approaches to conservation, resource management, and conservation and governance of the Arctic region. Space-based assets are a critical element to providing information and infrastructure to develop some of those solutions. Space through remote sensing satellites plays an important role in monitoring the changing conditions in the Arctic, both those caused by humankind and that which is naturally occurring, and enabling the management of resources there. The Arctic region also depends very heavily on space assets for communications and also for situational awareness, primarily maritime domain areas. Given that the United States will assume the chairmanship of the Intergovernmental Arctic Council this April, and at the White House just last week issued an executive order to coordinate U.S. Arctic policy. This timely, we hope, panel discussion will examine the implications of changing Arctic conditions, what the United States and international community are, and perhaps more importantly, are not doing to meet those challenges being created by those changing conditions, and how space can help improve our understanding of and mitigate the disruption from those changes. So when you guys came in, you should have all received bios of our speakers, so I will skip right to our first speaker, Mike Sigtart.
Hi, thank you, Victoria, and thanks to the Secure World Foundation for hosting this great event. I think I'm probably the only speaker up around the panel who's not a space expert, who doesn't know much about the capabilities or limitations of space, so I get the easy task, I guess, of being able to wish for everything and say these are all the things that we want space to be able to do for us in the Arctic, and not be constrained by actual laws of physics or any other limitations. I'll leave that to the rest of my panelists. But as Victoria said, the Arctic is changing. It's undergoing a great deal of change these days. And one of the big implications that is already starting to be seen from that, and is anticipated to be even more so in the future, is the increased level of human activity in the Arctic. So we in the United States government and Arctic countries around the globe need accurate and timely information to be able to make the right policy decisions now with respect to the Arctic. And having that information is critical. We need to know what's going on. And we already get a lot of information from space that we use for the Arctic. I know the ICESats that used to be up, and then IceBridge, currently going now, has been able to provide a constant record to track, among other things, just sea ice extent in the Arctic. But there are many other things that we can use, or that we see that space can play a role in giving us this information on the Arctic. So I'll talk about some of the challenges that we have in the Arctic now. As the sea ice extent continues to recede in the Arctic, it has opened up or made more accessible areas of the Arctic Ocean for everything from shipping, including commercial shipping, tourism, oil and gas exploration, even undersea mining, access to fishing grounds, as we see fishing stocks look like they're continuing to move north as the ocean water continues to warm, or the degree of it moves north too. We don't know what those changes are or how to predict them very well, and how to act on those right now. So the more information we have about what is actually happening in the ecosystem and with respect to the ice, the better. So there are tremendous opportunities opening up in the Arctic with exploration, shipping routes and mineral exploration, but there are also challenges that this presents. Part of it, because of the increased human activity in the Arctic, is a challenge. But even if there was no human activity in the Arctic, the challenge of being able to tell what's going on in the Arctic and react to it properly. So the Arctic Ocean is suffering the effects of ocean acidification more than other regions around the world, just like as the Arctic itself has been warming more than other areas around the world. The carbon dioxide that's in the atmosphere is more soluble in colder water, and it has more of so the water in the Arctic Ocean is more acidic. We're seeing more acidification of the Arctic Ocean in other areas. That's potentially affecting marine life, subsistence hunting in areas, migration patterns of whales, not by the acidification, but the sea ice extent. Polar bears and other marine mammals are also being significantly affected by these changes in the Arctic. So I don't know if there's a way to measure ocean acidification from remotely using remote sensing, but as in remote sensing has been used in many other areas by seeing symptoms of what happens and then taking those signals from those symptoms that happen, making inferences or determinations about the underlying cause for that. Maybe there's a way for ocean acidification to be more measured from space. As an example, is something that's way out there that I don't even know if anybody has even looked at. But ocean acidification is one of the major areas of concern in the Arctic right now, and one of the areas where there is not sufficient monitoring or observation terrestrially on in the ocean to be able to get a good picture of what is actually happening. Other things that other types of scientific observations that are probably already being used from space and that can continue to help us and help us even more in the future. I've mentioned sea ice extent trends, methane tracking, both methane that comes from thawing permafrost and methane that comes from any methane hydrates that might be melting and being released in the Arctic Ocean. Glacial melting itself. One of the things that we have used satellite tracking for now, but we need more information on too, is the shipping traffic that's actually there. I guess I'll let Ron talk more from the Navy about how the Navy uses that. But I know that the shipping picture, the state of Alaska, as well as the other Arctic stakeholders, around the Arctic Ocean, have told us that they do not have a good picture of shipping because ships don't always say when they're going to be transiting your area. And that is a significant problem in the Arctic because with an area that has so much ice and so many natural hazards, if the ship runs into trouble, you might not hear about it until they're actually washing up on the rocks. And then their oil bunkers have fuel bunkers have already burst open, you have a large oil spill. And in order to respond to that in the Arctic, to get a ship up there or anything to even start responding to it, it may take days. So these are some of the challenges that we're facing in the Arctic. So anything that helps us with knowing what's going on sooner, better, more in advance is helpful. One of the other, I noticed in the title of the panel today is Sustainable Arctic Development. I'm the U.S.'s representative head of delegation to the Sustainable Development Working Group in the Arctic Council. So we talk about sustainable development in our working group a lot. And what is sustainable development? What does that look like? And it means several different things depending on who the person is that you're talking to. For indigenous populations in the Arctic, they don't want their traditional way of life to be changed by decreasing access to subsistence hunting resources. But they also want the right to develop economic wealth on their own lands. So they have this struggle, whereas they want things to remain as they are for their traditional subsistence way of life, but at the same time, they don't want anybody limiting them based on what they can or cannot do with their land. So in trying to resolve that inherent struggle in defining sustainable development and being good stewards of the land up there, we in the government want to make sure that development is sustainable, meaning it takes into account how all stakeholders can benefit from development and in a sustainable way. And again, information is key into making those decisions. So that'll conclude my remarks. I look forward to hearing from the rest of my panelists.
Thank you. Okay, next we have Claire Parkinson from NASA.
Thank you, Victoria, and thanks very much for having invited me here. I'll follow on Mike's comments in terms of, I do have some slides here that will show some of the results for the sea ice and ice sheets. So, Victoria, the next slide. Okay, this one simply shows the extent of sea ice in the wintertime, which would be March, and then on the left, and then in the summertime, September on the right. In the March case, it's an area of 15 million square kilometers. The area of the U.S. is about 9.5 million square kilometers, so it's well over 1.5 times the area of the U.S. Area of Canada is about 10 million square kilometers, so it's about 1.5 times the area of Canada that is covered by ice in the wintertime. In the summertime, clearly, it's a whole lot less, down to about 5 million square kilometers. Next slide. Because the ice extends over such a wide area and has many impacts, this shows 4. The ice really is a strong insulator in between the ocean and then the overlying atmosphere. It also is highly reflective, so an ice surface will reflect most of the solar radiation that's incident on it, sending that solar radiation back to space. This is hugely important in the climate sense. So because of the presence of ice in the polar regions, that contributes to keeping them colder than they otherwise would be. It also has impacts on many animals, the polar bear being the one that's most iconic and the one that people refer to most often, but also walruses and seals and Arctic foxes, and all the way down to little microorganisms that live their entire lives within the ice. So the ice really does impact a lot of plant and animal species, and amongst the animals that it influences would be humans. And we definitely are impacted by the ice. The particular picture there is just a schematic showing the impact on traveling through the ice, where it can be hazardous if you're in a ship. Of course, the ice helps us if we're on a dog sled instead of in a ship. So it's got many impacts, and because of the fact that it has many impacts and that it spreads over such a wide area of the Arctic region, NASA started getting imagery of the Earth back in the 1960s and 70s. Sea ice was one of the many variables that it wanted to try to figure out how can we best measure sea ice from space. Next slide. We can see sea ice easily from space with visible imagery. So Landsat takes visible imagery. That's the kind of radiation that our eyes see, and we see pictures just like what we would see if we were up in a plane. This is great as long as it's light out and as long as there are no clouds in the way. Well, in the Arctic, in the wintertime, it's dark for months at a time, and the Arctic also has a very heavy cloud cover frequently. So, therefore, in terms of our climate studies, we usually don't use visible data. We usually use microwave data instead. Next slide. With the microwaves, we can, the microwaves are coming from the Earth system. And so therefore, sunlight is irrelevant. So we don't need light. We can get our measurements all times of the year. And if you pick the right wavelength in the microwaves, they can go straight through the clouds. So therefore, we can see through the clouds to get our data at the bottom. The picture on the left was from the first microwave imager in space. It's from the Nimbus 5 satellite. And it was a proof of concept instrument. It did a phenomenal job in terms of showing us that indeed we can find out something about sea ice and lots of other variables with microwave measurements from space. However, there were lots of missing data. It was a proof of concept instrument, and it is nowhere near the quality of what we've gotten subsequently with the follow-on instruments. All those black areas are missing data. And that's for a three-day average. The image on the right, which is more typical of what we get now, the image on the right, you can see there's practically no missing data. There's a very little bit of missing data right smack at the pole, and that's simply because the orbit doesn't go exactly to the pole. But the image on the right shows the advance that we've had in the measurements through the microwave imagery. Next slide. So at first, in the 1970s and 1980s, we were basically looking at the microwave data to try to figure out what can we see about the sea ice. And we saw a lot of things. We saw that it was a lot more variable from one year to another than people had guessed. But by the end of the 80s, it became clear that we also really would like to see what kind of trends we're getting. And by the end of the 90s, these trends had become clear. Not as clear as they are now, but still clear. The top image here shows a plot month by month of the ice extent in the Arctic from the follow-on instrument to the Nimbus 5 satellite. The follow-on instrument was on Nimbus 7. It was launched in late 1978. And so that's where our data starts here. And month by month, you could see that every winter it's way more ice than in the following summer. And that seasonal cycle is so strong that it does dominate. So if you only have the top picture, it's not all that obvious that there's a strong trend. We remove the seasonal cycle to get the bottom picture, and removing the seasonal cycle then shows this trend that is clear by the time we published this, which we published it in 1999. The data went through 1996, and at that time, only 3 years behind. I mean, this was really pretty good for that time. Now, of course, we have data up till yesterday. So again, advances in what we can get from space. This particular set of plots came out roughly the same time as results from a group from the University of Washington, where they took submarine data to look at the thickness of the ice. And they found a significant thinning of the ice cover. So here we've got this combination of NASA showing the retreat of the ice spatially, as indicated in the bottom plot there, and the University of Washington showing a thinning of the ice. And this hit the news. I think the combination of the two was very powerful at the time. And since then, many, many more people are interested in sea ice in the Arctic and also in the Antarctic. So we have, next slide. And indeed, the sea ice retreats have become kind of like a poster child for climate change now. And just as illustrated by this cover of Time magazine, from back several years ago. And polar bears also have become kind of iconic in this realm of global warming impacts. Next slide. So we have continued to update our plots. This plot goes through the end of 2013. You can see that there were two really steep decreases in 2007 and 2012. And in 2007 in particular, for those of us who've been working on sea ice for many years, it was just remarkable how much that sea ice plummeted. And some scientists and others at that time, 2007, this would be September and October of 2007, some scientists and others at the time were saying that, you know, we could have an ice-free Arctic a whole lot sooner than had been predicted previously, and some were even saying it might happen within the next few years. Then, fortunately, in the subsequent couple of years, there was some rebounding, but then in 2012 it went down further, and it's rebounded a little bit in the past 2 years. Next. September's the month that people talk about most. That's because that's when it gets to a minimum each year. And here are those two extreme cases of September in 2007 and September in 2012. You can see in the 2007 case, the upper left, that you could really do a very easy northwest passage, but northeast passage you would still have some difficulties. And then you can see in the 2012 case that the northeast passage, you could just kind of sail through that really easily that year. There is interannual variability here, and last year there were 10 recorded cases of ships that did successfully do a northwest passage last year. Next slide. So even though September is the month that tends to be highlighted, every single month shows a negative trend. This plots month by month what the trend is over the period since 1979. And you can see that every month is a negative. At the top of the scale is a negative 30,000 square kilometers a year. At the bottom of the scale is negative 90,000 square kilometers per year. Area of Maryland is like 33,000 square kilometers. So every month is showing a decrease of ice that's kind of significant, a decrease per year. So next, we do update our results on a website which is indicated down at the bottom there. And so this is one of the several types of plots that we update every week. And you could, I just left it through 2014 here just so that you could see the black curve is 2014. You can see it's not as low as either 2012 or 2007, but it is well below the previous decades. Next. Another way of looking at it, and a way that's particularly relevant for polar bears, is the length of the sea ice season. And there too, we're seeing a prominent decrease in the length of the sea ice season. The prime result is the one on the right, and the length of the sea ice season is decreasing in every place where it's in the red, brown categories. It's increasing just a very few spots, mainly in the Bering Sea in the blue. The other two plots on the bottom left are showing what the same calculation gave when there was only 10 years of data and then when there were only 20 years of data. And you can see that as we've gotten more data, it's become more and more overwhelming, the decreases in the Arctic ice. Next. We do exactly the same sets of calculations on the Antarctic, and this just is put in to indicate that in the Antarctic, indeed, it's not the same results in the Antarctic. There has been an increase in ice, but if you look at the slopes, you can see that the slope for the Arctic is just way more. In other words, the Arctic is losing way more ice than the Antarctic is gaining. The Antarctic is roughly a third gain versus what the Arctic loss is. Next. And however, last year in 2014, there was press coverage on the Antarctic case because it reached its maximum over the from the satellite record period in last September. And so you can see that, yes, it's definitely high, and that's definitely of interest to scientists, but it's really not relevant to the fact that the decreases in the ice are really important to the Arctic. And so sometimes people confuse the two. They say, we don't have to worry about the Arctic because the Antarctic is going in another direction. But the fact that the Antarctic is going in another direction doesn't mean you don't have to worry about the Arctic. Next. So now I've got 2 slides left that look at the ice sheets. And the ice sheets are particularly important because there is a whole lot of ice left on the Earth, but the overwhelming majority is in the Antarctic ice sheet, and the next overwhelming most amount of ice left on Earth is in Greenland. Enough ice in these 2 ice sheets to raise sea level by about 70 meters. So huge amount of ice left on the Earth, but mainly in those 2 locations. So therefore, since this has the potential of really being important to humans if sea level rises, the Earth can take it there. It's taken much greater sea level changes in the past. The Earth can take it. It's humans that are going to have a problem if sea level rises. So, so NASA indeed has, for many years, tried to make measurements of the ice sheets. And these are visible pictures, but in the next slide, you'll see some results from ICESat, which Mike had mentioned in his comments. From ICESat on the left, ICESat was another proof of concept type instrument, a laser altimeter, and it certainly showed that with laser altimetry we can get information about the ice sheets, and this shows changes in the Greenland ice sheet from the laser altimeter on the ICESat satellite. And as Mike said, ICESat's no longer up, but there's this bridge measurement program with aircraft measurements that's called IceBridge, and it's bridging between the ICESat measurements and ICESat-2 that will be launched, we hope, in a couple of years. On the right is a whole other concept of measurements. It's from the GRACE satellite, which stands for Gravity Recovery and Climate Experiment. And it's really very unusual in terms of it's got 2 satellites tracking each other, and it doesn't have any instruments pointing at the Earth, and yet it's giving us information about the Earth. And the way that it's doing that is it's keeping close track of how far away these 2 satellites are. And as one goes over a heavy gravitational field, it speeds up. And so therefore the distance between the 2 gets greater. And then as the other goes over that same heavy gravity field, it catches back up again in terms of the distance between the 2. So with that gravity information, you're able to tell changes underneath, and in particular the Greenland ice sheet, as the GRACE satellite has shown, decreases in the mass of the Greenland ice sheet. So I'll leave it at that. NASA is making lots of measurements relevant to the Arctic, and basically we tend to emphasize the measurements and rather than making policy recommendations. We're always told we can make whatever recommendations we want, but if we make recommendations, it's got to be as a private U.S. citizen, not as an NASA employee. Thank you.
Thanks. We've been doing a good switch. In the meantime, you say with Charity Whitney from the Canadian Embassy.
Hi, thank you, Victoria and Secretary World, for inviting me to this panel.
There we go. My fellow panelists have already mentioned some great applications that space can bring and their effects that Arctic environment changes have on Earth and the peoples of the Arctic. But today my remarks will focus on Canadian viewpoint of where and how space and the Arctic intersect. And the Arctic is a special place, fragile, yet full of opportunity both domestically and collaboratively. And as its access increases, so does its economic potential and human footprint. How the region evolves is of utmost importance to Canada as an Arctic leader and is embedded in our national identity, reinforced by our national anthem when we sing about the true north, strong and free. And access to space-based capabilities is integral to the safety, sovereignty, economic prosperity, and way of life for Canadians working and living in the Arctic. Indeed, as interest gains in the region, space will play an even greater role in its development. The 4 pillars of Canada's Northern Strategy are ideal in helping to identify how space supports our national interests in the region. First of these pillars is exercising sovereignty over Canada's north. Much of Canada's vast north is a harsh environment and difficult to reach. Consisting of 1.5 million square miles, an area about the size of the Indian subcontinent. It makes up 40% of Canada's total landmass and is home to 115,000 Canadians. That's 1/3 of 1% of our national population. Canada is also a 3-ocean nation with 2/3 of our 150,000-mile coastline in the Arctic. Of the 77 communities north of 60 degrees, 28 cannot be reached by road or rail. While it takes a suite of land, sea, air, and space capabilities to monitor this region, the unique qualities that satellites play in reaching isolated areas shows how ideally suited space is to monitor, navigate, and communicate. Basic requirements to support sovereign operations in the north. Remote sensing satellites, and in particular synthetic aperture radar, provide wide area detection and of transits through the Canadian archipelago, fishing or instances of pollution, day or night, in any weather. Space-based automated identification systems, or AIS, further identify and track maritime vessels, helping decision makers narrow down where to send air and sea assets. And global positioning satellites aid in the navigation of territory when inertial systems drift closer to the North Pole. Finally, satellite communications pass vital time-sensitive information in the event of a search and rescue effort or an environmental disaster. And while communication gaps still exist in the Arctic to support safety and sovereignty operations, the Government of Canada is pursuing solutions like Polar Communication and Weather, PCW, to provide access to secure, highly reliable, and high-capacity telecommunication systems in this underserved region. It's true that space technologies do not replace humans and infrastructure on the ground, but they are naturally suited to reduce gaps where physical presence is extremely difficult to maintain and provide critical support when conducting operations in the Arctic. Secondly, is promoting social and economic development. In the fall of 2011, Anik F2, a telecommunications satellite that serves the North, encountered a software malfunction. While you and I likely did not notice, 39 isolated communities that receive phone service via satellite across Nunavut, the Northwest Territories, and the Yukon certainly did. The malfunction also affected internet connectivity, ATM access, debit machines, and even grounded flights. It goes without saying that assured, affordable, high-speed internet access is critical to the economic development of the North. While there are fiber and microwave options in a very few select communities, satellite broadband of up to 3 megabits per second is currently the only limited option for the majority of our Arctic people. As an example of usage of this technology, teleeducation and telehealth services can make positive impacts for communities who would not otherwise have access to specialist doctors or professors. Further, weather data and ice monitoring from space is providing information necessary to allow barges, merchant, or cruise ships to safely conduct business and increase the economic footprint of the Arctic. Connecting Canadians, no matter where they live, is a fundamental reason why Canada became the third nation in space in 1962, and why we were the first in a series of communications satellite developments, including mobile services and domestic geostationary communications. And as economic development increases through mining or hydrocarbon exploration, tourism, or other innovative opportunities, space-based systems are surely to play a central role. The third pillar of our Northern strategy is protecting our environmental heritage. Canada's North has fragile and unique ecosystems, which are being affected by the impacts of climate change. It's important to understand and protect these environmentally sensitive lands and waters, and space-based capabilities are playing a significant role in doing just that. The atmospheric chemistry experiment on Canada's SciSat satellite has been measuring stratospheric composition and ozone levels in high Arctic and around the world for the past 11 years. Its data are making an important contribution to international environmental policymaking. RadarSat-2 and other remote sensing satellites are measuring both the extent of ice and whether or not it is multi-year ice, an important indicator for the pace of warming in the Arctic, which affects the habitat and migration patterns of Arctic animals. As permafrost melts, this technology can also monitor vegetation changes and measure infrastructure damage. Weather information, much from satellite sources, underpins all activity in the Arctic. Any operation, whether land, sea, or air-based, requires accurate forecasting for safety purposes. Should there be an environmental disaster, the effects are felt much more severely in the delicate Arctic environment. Detecting oil slicks or bilge dumps early helps to enforce regulations, expedite a cleanup response, and enable the prosecution of the offender. Canada's final pillar in its Northern strategy is to empower Northern communities, providing greater control over their economic and political destinies. Space-based tools are at their disposal to enhance education, healthcare, and social services. Self-governance is supported by space through being able to independently monitor resources and communicate with businesses looking to invest in the North. Now, I've been discussing how space capabilities bring benefit domestically to the North, but I'd also like to note that space and the Arctic are natural domains for collaboration. The Arctic Council is the leading multilateral forum that has produced consensus on search and rescue operations in the North, enhancing ship safety and protection of the Arctic marine environment. We all benefit from NASA, NOAA, and ESA science satellites to help understand and monitor the atmosphere and weather patterns in the Arctic and around the world. The sharing of ice and weather data is a public good that can save lives and prevent ecologic disaster. As with many of our space efforts, Canada looks to partnerships for mutual benefit and to obtain services and technologies that would otherwise be unavailable. After all, what affects one affects all of us. Clearly, space-based capabilities bring positive value to Arctic activities, whether through monitoring the environment, providing safety and security, or developing economic opportunities. Space assists Canada's commitment to be a consistent champion of the Arctic and do so in a manner that is peaceful, responsible, and in the interest of all Arctic nations. And as I close, I wanted to give you a literal example of where space and the Arctic intersect. And I have an image that's loading. That's okay. If it doesn't work, it's the Aurora Borealis. Exactly, literally, where space and the Arctic intersect. And it's beautiful. It absolutely is beautiful and stunning to see the northern lights dance around. With that, I thank you for inviting me, and I welcome any questions you have afterwards.
Thank you, Charity. Maybe it'll show up at some point. In the meantime, we'll have Amy Sun from Lockheed Martin talk about her work with the Arctic.
Hi, thank you for having me. I'm from Lockheed Martin. We're the prime contractor for the nation's next generation tactical SATCOM system, the Mobile User Objective System. This is a evolution of a tactical SATCOM system, a beyond line of sight communication system. And what's been exciting recently is this type of communications has been important since about the 70s, and traditionally we've had incremental improvement on the technologies that give us more gain, better coverage, better links, faster data rates, and recently with the Mobile User Objective System, it's MUOS for short. With MUOS, there's a revolutionary change in the underlying technology. And we've discovered that we are able to close high data rate links well into the Arctic. Now this is pretty exciting because MUOS is a geosynchronous constellation. So when you design a space-based system for Arctic or Antarctic coverage, you find that traditionally you have to go into funny orbits that have their own difficulties or different considerations. And the geosynchronous orbits are very well understood from a user's and Earth observer's perspective. The satellite essentially stays in the same place for pointing. It's symmetric for the Arctic and Antarctic, and it has a more benign or stable space radiation environment. So it's really desirable, if you can, to extend your, in my case, communications capabilities from a geostationary or geosynchronous orbit rather than these more difficult Arctic reaching or Antarctic reaching orbits. So recently, we, in 2013 and 2014, we, along with a group of other vendors, have ventured into the Arctic and Antarctic, proving that we are able to make these links. It's been pretty exciting. We've flown over the North Pole in a C-130. We've gone out on the Navy's ice camp and maintained essentially internet-like network connections for the duration. We've also recently participated in a search and rescue-like activity in the I guess the high Arctic, so between Alert Canada as well as the icebreaker Healy while it was transiting. One of the exciting things about having a geosynchronous system is you don't have separate networks for, say, just an Arctic network and just an Antarctic network that you then have to bridge into your equatorial or otherwise global network. It is the same network. So we expect the same performance, be it latency or quality of service or coverage. I'm going to stop here because I want to break out in equations now, but I welcome any questions.
Well, I'll just say thank you for stopping before the equations got there. So.
Actually, before we pull up your presentation, please enjoy Borealis. Okay. And we'll be pulling up his presentation, and I guess you're running the slides? Okay, please, continue.
There we go. Thank you, Claire, and thank you to the Secure World Foundation for having us. I'm Commander Ron Perrette, and I work for the Navy's Task Force Climate Change in the Office of the Oceanographer of the Navy, Admiral John White. Give my regrets for Admiral Titley. Some of you are probably expecting to see and hear him this morning, but he gave me some of his notes, so hopefully I can carry some of the water there. Next time, Claire, too, I think I would like to go first after all these smart people had their say. Cleaning up last. I feel like there's a lot of great work going on, and the Navy's looking forward to leveraging some of that interagency work as well as international partnerships. We've been thinking about the Arctic for a while. We've been operating in the Arctic for a while. It goes back into certainly the 1700s when the Jeannette expedition went up there with Lieutenant Commander DeLong. Not such a successful endeavor. However, we have been continuing to operate in the Arctic continuously with our submarine fleet since 1958, and the Nautilus is surfacing at the North Pole at that time. We can go ahead and go to the next slide. So obviously the Navy's been aware of the increasing access to the Arctic, and unlike Dr. Parkinson's good radar images, this is the Navy's colors and pictures and our depiction, if you will, of what we see the future looking like, trying to tell a story effectively. And back in 2009, Admiral Roughead obviously saw that the Arctic was starting to opening up. We can see the impacts of climate change from a security perspective. And he turned to Admiral Titley, the then oceanographer of the Navy, and asked him to stand up Task Force Climate Change and take a look at some of these problems and what does it mean for the Navy and the nation as a whole. And so we wrote our first roadmap in 2009, really doing assessments and studies, trying to figure out what don't we know, where are we now in terms of our capabilities, and what questions are we not asking at that point in time. And we had a lot of success with that, and we did identify a number of things that we needed to work on and start asking those questions in collaboration with the Office of Naval Research and a lot of their partnerships, again, with the interagency and international. We pursued those lines. Fast forward again, we had ice minimums in 2007, 2012, and again, we're starting to talk more about climate change. So Admiral Greener, our current CNO, now asked Admiral White, the current naval oceanographer, to update that roadmap. Hey, what do we need to do? Okay, we've done studies, we've done assessments. Now, what do we need to do to prepare? And oh, by the way, I'd like to know, Admiral White, when is the Arctic going to be accessible to human activity? And there's some smiles in the audience, so that's a pretty hard thing to do, trying to model things. So what you're seeing up here is really our depiction of when we see the Arctic opening up about mid-2020s in terms of perhaps a transpolar route being accessible for maybe 2 weeks or so in the mid-2020s to 2030 timeframe. So what are the implications of that, and what does the Navy need to do to prepare for that human activity? And also, our formal job is securing the nation's interests with regards to that. We can go to the next slide. So part of the roadmap update was taking a look at our strategic objectives for the Arctic region. And frankly, they're much similar to everywhere else we are in the world. We ensure our sovereignty and provide defense. We have to provide ready naval forces for any sort of contingencies or crises that may occur, whether it's with our friends or for ourselves. Certainly preserving freedom of the seas and access for not only global trade and economic development, but not for just ourselves, but again for our allies. And an opportunity really to promote partnerships, both within our own government and with our international allies. And so we produced the roadmap, and there's a lot of focus really on leveraging those partnerships. There's a lot of talk about budget austerity, and the Arctic is no different. And so we have to look for those opportunities, particularly in a region where we have a lot of close neighbors, all right, and we share a lot of borders in that region. Well, the Arctic Council has stood up in effect to that, to recognize that with shared interests also comes opportunity for cooperation and helping each other out, ensuring that the native peoples who live above that 60-degree line also prosper at the same time other nation states do as well. We can go to the next slide. So these challenges, I think everybody can recognize them, and they're common, I think, regardless of service or nation. And our partners have many of those same challenges, whether it's ability to operate in that environment, the limited comms and satellite sensors, We have a lot of experience in the submarine fleet, but in full honesty, the surface fleet hasn't had a need to go up there in a number of years. Certainly the Coast Guard has maintained that presence and ability in the Alaskan waters with the Polar Star and the Coast Guard cutter Healy as well, and some of their summertime deployments. But certainly the search and rescue assets, we have 2 agreements now within the Arctic Council for search and rescue and hazardous spill response. Again, a lot of those things generally fall towards the Coast Guard first, but we work in cooperation, so we need to identify those instances where we think we need to complement those Coast Guard activities with regards to that. Kind of putting on my oceanographer hat, just quickly, we identified some gaps in terms of how do we sense that environment and how do we forecast in that environment, as well as predicting, providing the operators some sense of, hey, this is what's going to happen up there and you need to plan appropriately. If we could go to the next slide. So we built this plan in order to try to address these things. There are a lot of great efforts going on right now. I think you can do one more click with regards to that slide, or maybe one more after that. Sorry, I didn't realize I had animation in there. So we signed, it's almost been a year next month that we signed out this roadmap, and it's kind of divided into 2 parts. The first part is the strategy and our focus and how we think about the Arctic. And we do think about the Arctic as a place where we have a lot of opportunity to work with our partner navies up in that region and continue to develop those relationships so it remains an area of cooperation and shared interests as the national strategy also promotes it. And so we kind of also then broke it down as, in terms of the time frame, as the Arctic is going to become more accessible, what do we need to do? Well, in good acquisition process, we kind of need to figure out, do we have the right equipment? What are our requirements? And what are our enablers with regards to that? And that's kind of some Department of Defense speak. But if we go to the next slide, the enablers are really about what does it take to operate up there safely? What does it take to take a ship, an aircraft, a sailor, soldier, airman, and be in that environment that not only allows us to operate there safely, but this also has economic impacts with regards to the people who work up there, whether it's the petroleum industry, whether it's fishing fleets migrating to the north, whether it's mining operations and so on. These are all the things that we really need to kind of solve and get at so that we humans can work in the Arctic, not only in a sustainable economic fashion, but also with regards to stewardship. That all kind of links together. So under law, if you will, Title 10, the Navy's really, we're responsible for the safe and effectiveness of all the maritime traffic, whether it's aircraft, forces, or any sort of allied shipping on the water. That's not from a commercial aspect, but it's for the Coast Guard, our own Navy, any of our survey vessels that might go up there as well. And we first need to understand that environment, understand the physics in that environment, and then apply that in improved modeling, high-resolution modeling, and coupling the air and the ocean together. And that's not something that we do extremely well right now. So we have efforts ongoing not only regionally but globally. Some of you may be familiar with the Earth System Prediction Capability. And again, that's a number of agencies that are working together now to have a globally air-ocean coupled high-resolution model in order to predict weather and have ice characterization and things of that nature with regards to that. So again, how does space come into all this? Well, obviously it's a tough environment, and if you ever try to put a tide gauge in the Arctic or anywhere else, or put a buoy in the water, nothing wants to stay for very many seasons, right, Doctor? So remote sensing and satellite-based capabilities are really a key factor for us to get synthetic aperture radar and the imagery associated for ice prediction, as well as communications for the safe operation of vessels up in that area. Major Whedon also mentioned about AIS, or what we also use in terms of maritime domain awareness. So what kind of ships, who's going up there, understanding the risks involved. It's a very fragile ecosystem. And knowing the cargo, the type of vessel, where it's coming from, can allow us then to increase our response with regards to search and rescue, or figuring out what kind of risks, and risk models we're having up in that region. And as Mike noted, Alaska and the leadership in Alaska really wants to know who's transiting through the Bering Strait in their backyard that may impact their economic livelihood for the people on the North Slope as well. So I'll leave it there so that we have time for questions, and I appreciate the opportunity to speak in front of the group. Thank you.
Thank you, Ron. We'll have time now for questions and answers. I'd ask you just please wait for the mic and identify yourself. But in the meantime, I thought I'd start off with a question I had for it's from the panelists. Mike, I'm wondering if you could talk a little bit about the U.S.'s upcoming head of being the Arctic Council. Are there goals or objectives that we'd like to accomplish by the role? How can international cooperation work on that?
Well, I don't want to take up the rest of the time here. That's normally the topic that I get to speak on the most. I wanted to relate it to space, but as I was listening to the other panelists speak, I was thinking of areas in our chairmanship program that tie into that. So Canada right now is the chair of the Arctic Council, and the U.S. will be taking over as chair of the Arctic Council in April of this year, in just a couple of months here. And we have proposed some ideas for our program of what we would like to do during our chairmanship, or what we'd like the entire Arctic Council to work on during our chairmanship. And a couple of those areas do have direct relevance to what we've been talking about today. One of those is telecommunications in the Arctic. I think every panelist up here has talked about why communications are important in the Arctic and what role they play. Right now, communications in the Arctic need to be drastically improved in order for us to have better search and rescue capability, better services to the inhabitants of the Arctic, both just from simple emergency communications all the way up to having broadband internet access for telemedicine, for education, for everything else that the rest of us start to take for granted that we have access to and benefit from by having broadband internet access. But having been to the northern slope of Alaska and seeing what the internet rates are on your phone, data rates and that, you realize that how much you rely on that and take it for granted when you're not in a place that has it, and you see everyone else having to live day to day without that. So telecommunications will be a big emphasis of our chairmanship, and there are multiple other areas. But climate change, the effects of climate change in the Arctic, and understanding those and being able to take actions to improve the resilience and adaptability of residents in the Arctic is also an area we want to focus on. And I think that, as mentioned, the knowing what's happening by getting information from satellites and from space will help with that as well. But we have an ambitious program during our chairmanship. We've got 3 areas: improving the economic and living conditions of residents in the Arctic, addressing the impacts of climate change in the Arctic, and then also safe and secure shipping and stewardship of the Arctic Ocean. So those are the 3 areas. And then kind of as a side thing extra that we as the U.S. want to get out of it is we want to improve the awareness of the American public of what's going on in the Arctic, and help make sure that that American citizens are aware that the United States has Arctic territory by having Alaska. A significant part of Alaska is in our Arctic, and American citizens are affected by it, and so we need to make sure that, or we want to make sure that American citizens are educated about that through public relations campaigns.
Thank you. Actually, building off that, Charity, Canada is the current head of Arctic Council? Yes?
That's correct.
Okay. legacy, things you guys want to accomplish over the next couple months, things you guys have accomplished you're very proud of?
If you allow me, our Arctic subject matter expert from the Canadian Embassy is here.
Of course.
Nicola, would you like to answer that?
Yeah, would you mind using the mic? And could you?
Hi, so my name is Nicola, and I'm responsible for Arctic issues sort of writ large at the Canadian Embassy, although obviously Charity and others are the experts on specific things, but in particular I cover sort of the Arctic Council. I think I don't want to assume what decisions will be taken by the ministers at the end of April. But I think some key issues for us is work on black carbon and methane challenges, which, you know, have a big impact on people living in the Arctic, and we're think it's a U.S. plan to take this forward. I think I should just add that the Arctic Council is a consensus-based organization, so we're sort of going through the process of discussing the U.S. proposals, and hopefully we'll have good program agreed to by ministers at the end of April. Another sort of key thing for us is the Arctic Economic Council, which is an independent body, but was agreed to by ministers in 2013, and it's sort of for businesses to exchange best practices, to coordinate east-west, because pretty much all economic activity happens north-south. So I think another part of our chairmanship is sort of raising awareness about traditional life, traditional and local knowledge, so complementing sort of Western science with what the people who are living there actually have seen for themselves. So I know there's sort of several examples of that where often Western scientists only go up in the summer and stuff like that. These people live there year-round, also have a long history to you know, reflect on what they're seeing. How does this fit in with Western science, and sort of meet the rigors of that, but also recognizing that importance. So, you know, I could probably talk for a long time about Canada's chairmanship priorities. I guess one last thing is the agreement on oil preparedness and prevention, to sort of how to deal with that particular challenge. But yeah, I think I'll sort of end there and pass it on to other questions.
Thanks. You may put you on the spot, but that was very helpful. Thank you. Thanks, Charity. First question.
For Mr. Young, I'm Mark Brender. I'm the Executive Director of the Digital Globe Foundation. Of course, Digital Globe, the company, owns and operates high-resolution Earth imaging satellites. But with the change in the Congress's control and the upcoming chairmanship, you get any anecdotal sense from the appropriate new committee chairman how they're going to look at the Arctic now that they are in control of both chambers?
Well, Senator Murkowski has made well known that she's always been a big supporter of the Arctic and wanting the federal government to be more involved in the Arctic. And now that she holds prominent positions on a couple different committees that with appropriations, and that she has indicated that that she would like to use that to help support Arctic development in whatever way she can. As far as how the details of that will be worked out, I don't know what she has in mind or how that will work its way out amongst the rest of members of Congress and then within once it comes to the executive branch. But I know there's a strong interest there. Yes.
Hello. Hi, Melissa Hirsch. I'm a risk consultant. I have more of a geopolitical question that I think would go probably to the State Department and to the Navy, maybe a little bit to Lockheed. Basically, with the U.S. taking the helm for the Arctic Council, what's likely to be the information exchange between the U.S. and Russia, predominantly based on the seemingly tactical advantages that Russia's had in the Arctic and based on the current relationship.
Well, with regards to Russia, the United States, despite what the sanctions that we have on Russia because of their actions in Ukraine, which we're obviously going to keep in place and keep trying to influence Russia to withdraw from Ukraine. The Arctic is a region where cooperation with Russia is in our own national interests, and it's in the interests of the entire region. It's in Russia's national interest to cooperate in the Arctic internationally as well, and so both sides see that, so both sides want to maintain that cooperation in the Arctic. Has it been affected by what Russia did in Ukraine? Of course. But both sides are trying to minimize that effect to maintain the degree of cooperation that all the Arctic countries share on Arctic matters. How that will eventually play out, I don't know, but so far how it's played out in the Arctic Council is there have not been any detrimental effects to that, and we still enjoy discussions and cooperation with Russia on Arctic Council matters.
Other thoughts?
I can comment briefly. Certainly we take the guidance with regards to our relations with Russia from the Department of State, and we had been having several discussions up until the situation in the Ukraine occurred, and since then those conversations have become much less frequent with regards to that. I will say though that we have hopes for collaborative efforts in the future. If those differences can be resolved, there's lots of opportunities in the Arctic with regards to charting and information sharing that would benefit both nations.
Yeah, I'm Jim Baker from the Clinton Foundation. I was interested in your thoughts about the increasing push by the oil industry to do more drilling. Obviously, there was an article in the New York Times about the big platform that they had some problems, but there's a continual push, and as the ice declines, there'll be more. But that will obviously have a big impact on all the things happening in the Arctic. What does the panel feel about that push by the oil industry?
I can start out, Jim, and say that since I've worked on the Arctic for 7 years, from very early on, many of us in the scientific community see that this is a danger of, we really wish that minerals, oil, and other valuable things would not be discovered in the Arctic or the Antarctic, because we see the potential of the environmental destruction coming from the Arctic. Again, this is really stated as American citizen, not as a necessary to go on. Certainly, with the opening of the Northwest and Northeast passageways, oil spills are going to become much more likely, just more ships can be up here. And then with the drilling, as you mentioned also, it's just disasters are much more likely. So certainly, as a scientist, it's definitely.
Well, yes, interesting question, and I read the article as well, and it goes to show that operating in the Arctic is still not an easy endeavor. Ice-free is not a word that is commonly used because it's ice-reduced in the summer, but navigating in the north is still an issue with knowing where ice is and boundaries, etc. So from a government perspective of making sure that the right infrastructure and the right responses to an emergency search and rescue or environmental disaster are clearly important and in our interest.
I'd like to comment a little on that too. So the U.S. government's policy is that we are not opposed to oil development in the Arctic, but we want to ensure that it is responsible. And I would say that of the other Arctic countries right now, the U.S. probably has is the most leaning on putting more emphasis on the responsible side of that as opposed to the development side of it, just by the nature of the different governments and different national interests around there. So we're not opposed to oil development in the Arctic at all. We need to make sure that it's responsibly done, and the technology to be able to do that right now does not really exist. The technology to explore for oil responsibly exists, even though there obviously you can't account for poor judgment, as in the case of the Kulik. But the technology to actually produce in offshore wells in the Arctic does not currently exist. And one of the areas that we're working on in the Arctic Council right now is the task force on oil pollution prevention. That's kind of twofold. It's there's the shipping aspect that we've been talking about. If a ship runs aground or fuel bunkers are ruptured. But there's the other one if there's a blowout from an oil well in the Arctic, which everyone looks back to Deepwater Horizon and thinks, if that were to happen in the Arctic, it would be so much more disastrous than it was even in the Gulf of Mexico. Because not only is it remote and you can't get resources there, it could potentially be under ice. The oil is mixing with the ice, not able to be cleaned up or dispersed. Even so, when you talk about risk management for oil production and including exploration in the Arctic, the standard has to be so much higher than it does offshore than it does for anywhere else in the world. And like Charity was saying, the Arctic is not an easy place to operate. Even with things opening up, there's been a lot of hyperbole, in the media about how the Arctic is opening up, and suddenly everyone thinks, oh, it's almost like a step function. It was closed and now it's open. Everybody rush, forward, and that's not the case at all. It is still very difficult to operate up there. There are technological challenges. We have overcome some of those technological challenges before. The oil companies have done amazing things on the Alaska North Slope with their ability to develop the Prudhoe Bay fields and building the Trans-Alaska Pipeline system and that. But when you start going offshore, it's a whole different realm. And if you're going to be producing offshore, you want to be producing 12 months of the year, not just 1 month. And producing under the ice, you can't have a platform that's on the surface. No amount of structural strengthening is going to keep a oil platform on the surface from the sea ice engulfing it, and the sea ice moves, and so the sea ice, those forces are just insurmountable. You have to either build artificial gravel island, like we've done in some of the cases off the North Shore, which is basically creating a land-based shore in shallow water that we're able to put enough gravel down. But if you do it in water where you can't do that, you don't have a way of grounding it to the sea floor where the ice isn't going to be able to move it. So you have to be able to produce basically a remote wellhead that's produced remotely under the ice in the dark. If everything goes great, that works out well. But you can imagine if you're producing remotely this wellhead and then something goes wrong to the pipeline, that goes up to land. How do you respond to that and do that? And so there are several challenges that need to be overcome in order to produce responsibly. So we're not opposed to producing responsibly, but it does need to be responsible.
Sorry. Just a follow-up question on that. In terms of underwriting and indemnifying any of the potential commercial operations in the Arctic, is the U.S. looking to work with the private sector? Or are they looking to share some of that burden themselves? Is there discussion on how that's going to take place?
I'd have to refer you to the Department of the Interior on that. I'm not familiar with those issues.
I guess I'd just like to make a further comment echoing what Charity and and Mike have said, but also to realize that there are at least two very distinct Arctics. It's important to note that, for example, Norway has been extracting oil and gas from its Arctic for about 50 years. So this isn't new. They're able to do this, however, because of the Gulf Stream. Canada has issued some exploratory leasing, but no drilling is actually taking place there right now because of the challenges that Mike has identified. So I think just to add, the U.S. and Canada face these huge challenges, but it's important to note that it's already happening in other parts of the Arctic for reasons because it's very different there.
We have to take it for the audio recording, sorry.
There you go.
Richard Rogers from Stellar Solutions. I just have a general question. Can someone clarify what the sovereignty situation is in the Arctic, where the boundaries extend to, and who owns what?
Just for the record, before this event started, I asked, who's been to the Arctic before? And I was told there's many different versions of what the Arctic is. So actually, I had that question myself.
I'm probably, as the State Department person, I'll take that since it's a sovereignty question. So this is another one of those things that's written about in the media that's not portrayed in quite the correct way, and it all stems from the extended continental shelf claims. So the actual land in the Arctic, they're very well. There's one tiny little island that's disputed between Canada and the Kingdom of Denmark. But other than that, there are no actual land disputes. There are maritime boundary disputes. So the U.S. has one with Canada in the Beaufort Sea. But what I think you're probably referring to, probably based on those articles, is when they say, that there have been these claims. So like the Kingdom of Denmark just made a claim that they submitted to the Commission on the Limits of the Continental Shelf to claim a huge area of the Arctic Ocean. Russia has previously claimed that. Canada at the end of 2013 made their claim. Those claims are done through a very structured and scientific process through the Law of the Sea Convention in Article 76, and it spells out, based on certain criteria, the bathymetry and the sediment composition, everything of the ocean floor. If you can show that you meet the criteria that shows that beyond the 200 nautical mile normal limit of an exclusive economic zone, there's a natural extension of your continental shelf, then you can claim rights to the seabed floor and below. And so it's getting those rights. It's not getting extra territory or land. So those rights could be very valuable if there are mineral resources under there, oil, gas, magnesium nodules, whatever you have. But the process for making those claims is you do a lot of research, seismic testing, and that to find out what the composition of the seabed floor is. If you have a ridge that extends from your continental shelf, then you can prove that it's connected to your continental shelf. Then you can say that ridge is also an extension of your continental shelf and can make claims to either side of it. So there's a ridge that goes across the floor of the Arctic Ocean called the Lomonosov Ridge. It goes between basically right where Canada and Greenland come together all the way over to Russia. And so that ridge is one of the main reasons that creates the basis for all three of those claims. And and so as far as where all the Commission on Limits of the Continental Shelf will decide, which is a group of scientists, is whether your data that you've provided is in accordance with Article 76 and it proves that you have a valid claim. It does not arbitrate claims where there are overlapping claims between different powers. So in cases where there are overlapping claims, that's either a bilateral issue, or if there are more than two places overlap, a trilateral issue for those countries to sort out themselves, just like a normal maritime boundary claim. So it's not a, if we don't grab it, then someone else will get it type of scenario. So hopefully that answered your question a little bit.
Regarding the question, I'll just give the comparison with the Antarctic. wonderful it is that way back in the 1950s, the world did come together as far as leaders countries did, and made the Antarctic essentially dedicated to peaceful purposes, and all the major countries. So it's wonderful that it's not that in the high Arctic.
But I'd point out that there's a very big difference, though, because the Antarctic is land and
Yes.
the Arctic
Yes.
Ocean is ocean, and so
Huge
even,
difference.
so even legally,
Agreed.
there's a big
Agreed. Huge
difference. But one of the things during our Arctic Council chairmanship that we want to explore with the other Arctic states is whether the Arctic Ocean there should be some sort of regional seas agreement or regional seas program, whereas we can manage the Arctic Ocean in a way, just to explore the possibility of that. Not saying that we have an idea of exactly what that should look like, but we think that, the Arctic Ocean is definitely a maritime environment, and it should be explored because it is very fragile, and it's a very important ecosystem, that the countries that border that ocean should, explore the possibility of managing that ocean collectively. And that might, but there are areas of the Arctic Ocean that are on the high seas that, according to international law, it doesn't belong to anybody, and you couldn't exercise authority. Even if with extended continental shelf claims, that's only for the seafloor and below. It's not the pelagic resources, so it doesn't involve, fishing or anything like that. So when you talk about managing a regional sea, how, exactly what that would look like, that's something that we're going to explore.
Just building off of that, the International Maritime Organization adopted our national code for ships operating in polar waters. Is something like, I was very interested to hear about that, because for the space community, there's discussions of a code of conduct. And I'm wondering if there's some sort of similar mentality for entities operating in the Arctic or not.
I'm not sure I'm understanding your question completely.
Well, I'm looking at
the idea of, is there sufficient international cooperation to have some sort of code of conduct for countries that are operating for, like, for example, maritime domain awareness in the Arctic, or looking at, is it just surely, does it need to be done via legal treaties, or can we do it in an agreement of what the norms of behavior for responsible actors in the Arctic? And again, I don't know if that.
Yeah, it still might fall into Mike's realm in some respects with regards to treaties and the legal purview and the law of the sea, if you will. But, the nation states do recognize the law of the sea. We do operate underneath those conventions, and it seems to work well, across the globe.
Yeah, speaking of the IMO, the IMO recently adopted the Polar Code, which is, I'm not familiar with the code of conduct in space, so I'm not qualified to compare and contrast the difference between those, but the Polar Code that was recently adopted by the IMO does require vessels to, legally, all vessels for all members of the IMO, which is pretty much everyone in the world, to abide by certain regulations in both the Maritime Pollution Agreement and the Safety of Life at Sea Agreement. So there are pollution standards that were adopted as far as both discharging bilge water and also emissions, air emissions from stacks, operating in the Arctic. There's more that's that some people say the IMO could do or should do, but the IMO is a very large organization, and you need to get everyone to agree to it. But the Polar Code was agreed to, and that will be going into force soon.
Thanks. Hi, Corey Springer from Ball Aerospace. There's been a number of mentions about methane in the discussions, and that in combination with the recent administration policy on methane reduction, is that translating into any particular program in monitoring or measuring methane? Obviously, it's technically possible to do it from space. Doing it from space would be lots of advantage from doing it from space, but I'm just wondering if that's actually translating to anything at NASA, or and then considering a question earlier, if so, how do you think that may actually gain any traction with the new Congress?
Atmosphere of competition is key one is water vapor, and then CO2. So methane cuts down the risk. It does get some.
If I take off my Lockheed pin for a moment, and I can say that this is maybe a area where the sharing of scientific data with Russia comes into play. The majority of trapped methane that can be released by receding sea ice is in the region north of Russia. It's somewhat known or well known in published literature that the Russians have had various kinds of monitoring and experimental programs looking at and predicting the release of methane. And as far as I know, the British, Americans, and Canadians don't do it as much. We don't have as much trapped methane in our sea ice. So.